Welcome to part 6 of my ECE 5000 project video. This part is the final demonstration and the verification part. Uh, I will be demonstrating and verifying the functionality and use of my project, which is HomeGuard Climate Assistant. This is pretty much an Arduino based home assistant based temperature humidity sensor with a webcam integrated into the system itself. So what is the fundamental problem we're trying to address in the project? The fundamental project for the problem that I believe for the project is the fact that you want to monitor your surroundings, and it doesn't have to be just at home. uh, it can be in a greenhouse as well, where you have to constantly monitor your temperature and your humidity. Uh, and if you want to do it at your home as well, for example, my grandfather, he was pretty sensitive to heat and humidity when he got older. So everything had to be monitored in the house. Uh, and also, as he was getting older, we felt that he had to be kept in constant supervision as well. So we installed cameras in the house so that we could monitor him on every second of the day. I took a lot of my inspiration from that, and I came up with my project, which is basically HomeGuard Climate Assistant, right here. So everything, all the money that we spend behind my grandfather, monitoring his temperature and his humidity, uh, and also his supervision through a camera, can just be simplified down to this product itself, where everything is all inclusive in the system itself. So let's run by a few product features. What we have here is the HT11 sensor, which is exactly this here, which I have put on as a whole right here, which will sense the temperature and the humidity. And inside, we have an Arduino R4 Wi-Fi module, which will basically help the temperature sensor send data to Home Assistant, which is a cloud-based platform. I will be showing it to you in a while, which sees and records a lot of various activities, just not limited to, let's say, temperature and humidity. It can also be used to control light and also, let's say, install switches. It also has remote integration of YouTube and Spotify and whatnot. It's a very versatile app, but I have personally decided to go ahead with this feature. So we have Home Assistant, as I just mentioned, and you can also, the system makes sure that you can also integrate a webcam. And alternatively, what I have personally used in this project is an old Android phone. It's actually right there. It's recording, as if I'll show you right now. It's recording right there, as you can see. My phone is set up on that side. Uh, and to run that old phone, can be new phone as well, but I'd suggest using an older phone which you're not using as much. So you can just plug it into the power supply to charge it, and also connect it on the side, put it in a secure location where it can see and detect the movements going on. And the app you need for the old phone is the IP webcam app, which you can download from Google Play or Apple Store. I have Android, so I'm using this one here. I will be showing you shortly how to actually go ahead and install the whole system into Home Assistant itself. And the laptop, which acts as my primary source of monitoring device. The IoT, the Home Assistant, is an Internet of Things application, which I'm accessing through my laptop, which I currently have right now, and running this stream here. How about the box? So the box here has been completely 3D printed, and this is the shape of a cube. As you can see, I have the name of my product right here, and this is the DHT sensor, as I said earlier here. And when you see inside, you can see that there's two holes that I've drilled in and fit two screws and nails in the back right here. And worth mentioning that when you install such screws here, it's not exactly very level when it's on the field. And to actually tackle that issue, I have installed four floor levelers right here, as you can see. So when it's on the actual surface itself, it stays completely steady and does not lose any balance, which is essential for a sensor of this kind. So how does it work? What it necessarily does is that the Arduino is pretty much a little computer, and the sensor senses the data and sends data to the Arduino, which the Arduino wirelessly transmit through the Wi-Fi to the MQTT server, which is a Mosquito server, which then further integrates the actual the data itself into Home Assistant. So, what is MQTT? MQTT is basically like a server which you have and you can sense remote data. It doesn't have to be, again, doesn't have to be limited to any kind of, let's say, temperature, humidity, can be used for a various type of data as well. And this is what I have gone through with the integration. I've used MQTT and I've integrated into Home Assistant. I will show you the code now for the software, which is looks something like this. So what I have done here, I have included three libraries, DHT11, this is the library for the sensor, and then we also have the Wi-Fi S3 library, which includes the Wi-Fi package for uh, the Home Assistant and also popsup.h. Then we have gone ahead and defined the DHT pins, which we will be connecting to the wires to. I can show you right now. So the DHT pin here is going into digital pin 2, and the DHT type is also DHT11, which I have used here. And then when you define DHT as DHT pin, DHT type, and then you connect Wi-Fi client, which is the ESP32 module built into the Arduino itself. And the PubSub client lets you access a lot of the client information on the cloud itself. Right, then we have gone on to define all our constants, such as the Wi-Fi passwords, and this is extremely important that when you use a home assistant and any kind of IoT device, that your device has to be on the same network, and I believe it's extremely important to do that. There's no way that you're getting access otherwise, from what I've researched. So I have connected to my phone here, S22 Ultra, and this is the password, and this is the the broker IP, or which is basically your IP, which gets ported into. This is a very generic 1883. This is what I always recommend connecting it to, and then you have your username, which you have to set up in Home Assistant to access the MQTT, and this is the password for that. As you go ahead, you connect, you void setup, and this your serial begin. This is the connect to Wi-Fi function, and then the client of set server MQTT server, which you're initializing through here. Then again, you go ahead, you take the float value for the humidity, and this is the function to read the humidity, and then you go ahead and understand the temperature, which you're recording in Celsius. And if it doesn't happen that way, this is the reading you get, fail to get reading from DHT sensor. Then you go ahead and print it out in the serial monitor right here, as you can see. And after that, you go ahead and also send it out outside into the MQTT as SNPrintf function, which temp message sends you the temperature, uh, and also the temp message and the 50, which is basically a parameter, and then more like a time setting for that. And this is in decimal places, and then you have the actual function here, which sends the data to stores the Celsius data and humidity data here. And when you have all this data here, you actually have to publish the data into some topics. The topics I have described are Mohib's house temperature and Mohib's house humidity. They basically take the data and keep the temperature and the humidity data into the topic itself, and the topic gets published into Home Assistant through, this is the MQTT topic as we're talking about. And to connect to the Wi-Fi, we have the serial printf. This is basically just to initialize the Wi-Fi, connecting to Wi-Fi. If it's connected, it says connected. If it doesn't, it says that failed. Pretty much, try again in 5 seconds. Same thing with the MQTT here. uh, Arduino client connected. If it fails, try again in 5 seconds. Right, so this is for the code, and I will be going ahead and just demonstrating how the Home Assistant dashboard itself looks like. Connection details, as I just said, just before that, I go ahead with the demonstration. I'll just go ahead with the connection details again. So what you have here is you connect all your pins here. These are the wires which you have to connect to the pin here. And digital pin 2, exactly right here, is what's connected to the DHT's information pin, the data pin. And then you also have to put V in and V and also the GND pin to the Home Assistant here. And then, as I said, you have to connect the webcam to any available USB port on the laptop. If you're using webcams, I suggest using an IP webcam, which is essentially Reolink and all of the other types which you can get, and you have to set it up separately as well. For alternative measures, as I mentioned, you can always use your phone, as I just said a little earlier, and make sure pretty much that all your connections are secure, the powers are going, and the actual setting itself is actually connected to the same network. And going ahead, this is what we have for the actual dashboard itself. As you can see here, I have the house temperature, and this here is the house humidity. It's actually getting pretty warm with 12.3 degrees outside. And this is the humidity plotter, which tracks the humidity right here. And I will be showing you that the sensor does work. If I, let's say, put my hand on top of this here, it will change the humidity and the temperature will rise as well in delays. And as you can see, it's changing a lot of the values on the actual plotter itself. And as you can see that there is a bit of a lag on the live feed, but I feel that it's pretty expected when it's on a connection, and that's completely fine. It's not much of a lag. It's probably like 2 to 3 seconds. Let's go on to Studio Code Server, which I have configured a lot of the YAML, which is basically the code for Home Assistant. So I have the one YAML here, which is, I believe, is the most important one, is this one here, mqtt.yaml, which takes data for the house temperature and the house humidity from the topic right here. And then we also have the configurations, which actually includes a lot of this is basically, let's say, a library or a function which you call into the configuration stuff, which is your main body of code. So I've included MQTT and generic, which is basically just a generic YAML. Moving on, I've included a few integrations which we call add-ons into the actual MQTT itself. What we have here is MQTT. This is one of my add-ons, and the other one here should be, let's see, where is it? Automations and scenes, devices and services, integrations. Yes, the one we have here is devices and entities. These are the entities that I have, and the cameras should be here, right here. These are the cameras which I have, and they've been configured through OnBeef is the name of the integration right here. If you go here, you add entity, you configure. I don't want to touch any of it because if it messes around, it's going to take a bit of time to set it up again. But these are the integrations I have, MQTT and OnVIF. Coming back to the design, again, as I said, there is a bit of a lag, but I feel that's pretty expected right here. This is the dashboard itself. And now let's going back to the actual brochure itself. We have a bit of a component specifications. I only have two. I have the DH11 sensor and the Arduino R4. And they're pretty much, the supply voltage is pretty standard, 5 volt for each. Doesn't take up a lot of power either. The power it takes up here is pretty much just 12.5 milliwatts. And here it's also pretty low, 8 milliamps of DC current and 6 to 24 volts of input voltage. That's actually pretty doable. And yeah, this is pretty much it for the video. Thank you so much for watching. I hope you enjoyed it. And